Good evening, dear students, faculty members, and valuable guests. This evening, our guest is Akman, the founder, director of Building Biology and Ecology Institute, Turkey. We are very delightful to have him this evening. Sustainability, building biology, and ecology are very much in the focus of debates regarding the future of architecture, built environment, and the earth. And we hope this talk will contribute on raising awareness on this very significant topic and broaden the perspective of our students. This semester, some architectural design studios in our faculty are working on sustainability issues. Specifically, first-year architecture students are working on eco-living project and making research on sustainable processes and solutions, ecological architecture and materials. They have also posted some questions on Padlet, which is a platform that we use for communication. We grouped them, and at the end of the event, we will pose some of the selected questions to Akman, in addition to the questions from the audience, of course. I'm leaving the word to Tanya. She's going to briefly introduce Akman first.
Yes, thank you for receiving and talking to us. So briefly, Akman, you completed your bachelor degrees at Mimar Sinan University, and then you continue your study in New York University and then in the Building Biology Institute in Germany. So since the 90s, around 30 years, you continue your academic study and professional practice on building biology and ecology. And you worked in Lick architectural office in Germany for almost 17 years on the international ecological architectural project and their construction. And in 2007, you returned to Turkey and you decided to pursue your research and practice in Turkey. And since then, you taught classes on building biology and ecology. And between 2012 and 2014, you worked as a consultant for the United Nations for the development program with a project called Increasing Energy Efficiency in Buildings. And you are the founding partner of EDS Plus Architecture, and you continue your professional careers on architectural design and practice. And finally, in line with this long-lasting relations with Germany and the Building Biology Institute, you founded in 2015 the Building Biology and Ecology Institute in Turkey. So you write and share your experience about this topic that we are going to talk about, the building biology and ecology in various platforms. So I'm sure, Hanbei, you give us more information about what is YBE, like Yapı Building Institute. I also invite our audience to look at the website of YBE. So basically, very few words, YBE, the Building Biology and Ecology Institute in Turkey, studies the effect of built environment on the earth of human and nature. And this institute creates content and share information, trains, organize seminar, conference in order to enable the spread of like independent information and increase the expertise and applied work on the field of building biology and ecology. So again, I invite our students to look at the website of YBE, explaining the 25 guiding principles of building biology, because it extends the interest from the sustainable architecture, innovative buildings, materials, medicine, and sociology until biotechnology. I hope I summarized properly. So thank you again for coming, and Akman, the voice is yours.
Okay, thank you very much also for your invitation. Well, I was in the NYU in the New York University for one semester, but that was long time ago. So My mother tongue is German. I learned Turkish later, so and started to forget English because nearly all the connections are in German-spoken countries. So in that case, maybe sometimes I will ask you some words in Turkish, and you should help me to explain some things better for the students. But I will do my best. Tanya, you said that you asked the students to read these 25 principles of building biology. That's fine, because my presentation, it's mostly the, let's say, the boring part, just to show a text and read it or trying to explain it. And maybe we can use the time better today while the students have read these 25 principles. Okay, the presentation today, Building Biology and Ecology, and I will try to explain. It's a very multidisciplinary issue and not so easy to explain, but I will try it. And next slide. Okay, we jump from here. So building biology, we are talking about in situ structures, how they can be, and the human being, the built environment, the nature, how they are connected with each other. And if we try to see it very simply in a triangle, building biology, it's the well-being and human healthy. So it's the built environment and the human, the relationships in between, and the building ecology. It can be sometimes the opposite of it. Doesn't mean that they work parallel, because it's a relationship between the nature and the built environment. So these relationships, it doesn't mean that they are always at the same time good for our health, or something which is good for our health doesn't mean that it's always good for the nature, for example. And another important connection in that triangle are the relationships between us, the human beings, and the nature. And we try to define that as a social and biological sustainability. So the social sustainability is a very important part of the building biology. And we see that without social sustainability, the building biology or ecological architecture or green buildings, etc., they nearly don't have any chance to exist. So these are these 25 guiding principles, and these 25 icons are designed by the German Institute, and all building biology institutes in the world. Also, we are using these as a standard icon, let's say. And these principles, we see them in 5 groups: healthy indoor air, thermal and acoustic comfort, human-based design, sustainable environment, and socially connected and ecological sound communities. And if you go a bit in the details, that was what I said, the boring part. So maybe it's not necessary to read them now, because the students have already read them, or can read these 25 criteria, principles in our website, or in the website of the German Institute, or in the website of the Japanese Institute. They are all the same. But if we point to 1 or 2 only, for example, to minimize the electromagnetic fields and wireless radiation, one of the criteria. And it's a very big problem, getting a very big problem, especially with the mobile phones, which we are permanently using, and some electro-smoke dangers, which are caused by the electrical system of the houses, for example. We can take them under control, but the wireless system, we can't take it under control, and the people want to have that everywhere. So the mobile phone must be connectable wherever we are. That's the standard of today. But it's a very new technology, and we don't have the long-term effects. So unknown future is expecting us in that case. The next criteria are the thermal and acoustic comfort, and the heating systems, for example, are important for that, to prefer radiant heat for heating. And there's a big difference between the convection in Turkish, the heating systems which blow the air, and the radiant heating system, it's like the radiation, like the heating effect of the sun, for example, and we can implant that in the building's heating system, and the effect to our breathing system is very dependent from that. So if we get, for example, asthma or not, it's depending from these heating systems mostly. The human-based design, harmonic proportions also from the cultural and traditional buildings, not to lose these knowledge, not to lose these proportions from the ancient times, and trying to transfer them to the architecture of the future. So later on I will show some examples which I think that they are the right examples for that, how you can take a traditional design and transform it to the future. And sustainable environmental performances, minimizing the energy consumptions and using renewable energies. But we see that using renewable energies are not enough to have a good performance, to have a that we can say it's a green building. We have to minimize the energy for the production of that building, for example. Then we can say that it's a green building. And in Turkey, what we have forgotten, let's say, providing the best possible quality of drinking water. So today we are buying the water which we drink, pay money for that. But in social higher developed countries like Germany, for example, the law says that the water which you have in your house, which is coming from the musluk, must be drinkable. You don't have to pay money to drink water, and you don't have to pay money to have fresh air to breathe. It's the same, water and air. So, and the socially connected and ecological communities, and the designing of the infrastructure creating a living environment that meets human needs, for example, and protects the environment, and select building sites that are located away from sources of contamination, radiation, pollution, etc. And these are not only, we can't do that with only designing a house. We have to design correct living spaces, and decentralization is a very important part of that. Not trying to push everything to the cities, but for example, with 50,000 people, you can make a very logical, design a living space, and 50,000 people are enough for that without needing more people. So the Germans made a lot of researches, and the result is that 40,000, 50,000 is enough for that to be a in situ and self-sufficient community or living space. The area of Frankfurt in Germany is a good example for that. We all think that Frankfurt is a big city, but Frankfurt has only 300,000 citizenships, or people are living in Frankfurt, only 300,000. But around Frankfurt are little towns which are not bigger than 50,000, and millions are living there. So they have a very successful decentralization politic, and that saves these social life in these areas. So if we try to make design as an architect, and it should be an in situ architecture, or it should be an ecological architecture, or healthy, etc., we need three things. One is the individual design, which we as architects are working on that. The next is we need building materials. In that case, we need natural building materials. And the third very important step is the process quality, işçilik kalitesi. And that's the worst part in Turkey, because we don't have these qualified people who can make the buildings in these quality standard. So Switzerland or Austria especially, they are very much more developed in these things. And what they push is the process quality. They don't push the architects, they don't push the producing of the building materials. They say the most important thing is to have good persons, qualified people who can build it. But the biggest circle here is the social sustainability. If in a region the social sustainability doesn't exist, then we don't have any chance for a long-term solution. We can design it, we can build it, we can produce the building materials, but in the long term, when it starts to live, in a short time it will, let's say, get to die, because the people without this social awareness will not know how to use these living spaces or how to use these buildings. So that's a nice picture, and it's in Uganda, in Kagwe. Many years ago, I made a little project there, and the house behind looks like it's a ecological building, looks like it's a in situ structure. They have this earth, they have the reed, and they have these natural building materials. And we can say, wow, what a nice idea, or what a nice solution. On the front, we see this billiard table. That's the next shocking part. So, what says this billiard table in front of that in situ structure? So that's the big question. And my opinion is that maybe this billiard table will destroy the process of the social sustainability in this area. And because of this billiard table, a few years later, maybe they will demolish, break down these building in behind, and will start to make something with metal, or something with bricks, or something which doesn't belong there. And as an architect, I think that we have to try to see these kind of pictures in that way. Not just saying, wow, billiard table, what a nice idea, but more thinking about what's the effect of this billiard table. Is it a positive or a negative effect? What will it be? So environmental awareness is a condition for the formation of an in situ structure in architecture. And that's the big fight in our brain with our ego and our eco. And depending on how much our ego or our eco is developed, depending on that, we make our designs, or we choose our living spaces. So maybe next example, these kind of structures can be built. How can these kind of structures can be built in the rural? It's a little town in Germany, Burgberg, where also I used to live. And on the bottom, this Ullmann family, I know them personally, good friends of mine, and they are farmers, very simple farmers. But these very simple farmers are living in this house. So that brings us to the question, are these now farmers, or are these people who are the living habits of the people who are living in the city? Yani köylü kentli kimlikleri, these identities. And in my opinion, they are living in the rural, they are living in a little town, in the village, but they are not, köylü değiller artık. And that's the chance of the rural, maybe, how it can develop. Also with the help of the ecological architecture, with the help of the environmental consciousness, and with building biology. And we are very much working with containers, and especially in Turkey with the COVID pandemic, here we see that people are coming to the rural and buying some containers and trying to show them as a building. On the left side, it looks like a stone covering, but it's painting, so it's an imitation. And we can say that the nomad culture, the popular architecture could look like that, and the popular architecture of an in situ structure is the opposite example. And the big difference between these two personalities are that on the left they don't care about their surrounding. They are nomads still, so they live somewhere and use it, and after they have used it, they go somewhere else. They don't try to protect it. And in Turkey, that's more the situation what we have. People are not taking care about the place where they are living, because they don't have a deep connection with that place. So, example with building ecology. I'm sure all you know these circle with the raw materials and the manufacturing, the usage, and of the life of the treatment, and then we reuse it or we recycle it, etc. But if we see that with numbers, we see that with the recycling or with the reuse, we can't make a good, we can't reach a good performance. The most part of a good ecological performance is in the producing part of the building materials, and we have to reduce that. So in some numbers here, for example, the primary energy which is necessary for manufacturing and recycling, for a wood frame, for a building in wood frame, for a building built in bricks, with bricks, or with reinforced concrete. And here you can see how big the difference is, how much energy I have to spend for these kind of three different types of buildings. So one example with this reduce part, sorry. Let's say, just as an example, we need a window for our building. We design it, and the need is a window. And here we take a decision and say, okay, it's a window, a wooden window, wooden frame, or plastic frame, or aluminum frame, whatever. As an architect, we have to take a decision. And what we try to reach is in situ building, ecological building, a green building. That is what we reach. So I will pass these slides now like a slideshow a bit faster. What happens? So all these steps need energy and resources. Raw material extraction. For that, we need mineral quarries, machineries, organic resources, manpowers, and then let's go on. Then for the production of these, we need transportation. Again, for the transportation, we need lorries, roads. We have to build roads. We use railway or train or sea transport, and we need refineries, gas stations. And that goes on to the manufacturing. Again, transportation is necessary, energy producing is necessary, and after the manufacturing, again, a transport to the dealers. And now when this window has reached the dealer, we as an architect or as a family who wants to build a house, choose this window. And again, the dealers needs energy, and again, a transportation. And finally, at the end, with all these things which must be produced, which use energy, finally, at the end, we only had put the window in our building. That's all, not more. So the difference now in that case, is it a wooden frame window or a plastic frame window or an aluminum frame window? The decision is getting suddenly very serious, because we are responsible of all these consumptions. And example now, build example with the parallel, that's the eco settlement in Aachen in 1994. I was involved in the design of that. In the red circle, you can see these 8 houses which we have designed, and it's a little village on the German-Austrian border. And here we tried to make it as much as possible correct. So using local generator productions. The energy system is a biodiesel with hemp generator. But these villagers, they also are producing this hemp. So they produce the raw material, what they use later on as energy. And we used local companies, its own water and the energy resources, the rape fields, kenevir, and the local engineers, the local architects, the local craftsmanship, etc. So as much as possible, we tried to do that. And as a result, that was this little settlement, 17 living spaces in 8 blocks, 8 buildings, made with a wooden frame and adobe bricks and reed heating isolation, all building materials which don't need much energy to be produced. And another picture from the same, and also the design language is very adapted to the traditional design of the village. So I don't know how much time I have. Can we have a little? Can you inform me, please?
Maybe to have some time also for the questions. It would be very good if you may finish maybe in 15 minutes.
Okay. Okay, I will try. Thank you.
Mm-hmm.
And that's the now some other examples, build examples. That's the institute, Building Biology Institute in Germany, and the values. And it was a yüksek lisans tezi, thesis. These values here, the variant 1 is the IBN building, and the variant 2, the same building. What would happen if we did build it in a normal, conventional concrete system? But let's save the time. You can read all these values later on and can compare them. I choose only some, let's say, interesting examples, how the performances of these buildings can be or must be. Another building is the Herba Farm. It's in Turkey, close to Turgutreis in Bodrum. And it was 2016 design of mine. And then later on, these two buildings, the books, the Birkhauser in Switzerland published it in German and in English. And in this book were 21 chosen examples all around the world which are karşılamak, the criteria which are yani bu yapı biyolojisi kriterlerini
correspond maybe
criteria. And we were very proud. These little simple buildings, they are really very simple, but the publisher chose them, and only 21 around the world, and one of that was this. So some details from them, with this reed isolation, simple wood without any paintings, etc. And on the left side, these panels, they are not gypsum boards, they are produced by paper, waste paper. And so some building materials, thanks that building, were firstly produced in Turkey, for example. Another example is our building now, the biohouse in Kadovacık in our village. And we made the carbon footprint calculations. Maxims Hüdayi Kara did that. And they find out or calculated that the foundations are in concrete of this house and the rest is built in wooden frame and adobe, etc. And 79% of the carbon footprint is causing by the fundaments, but the fundaments are only 17% of the house. So that also shows the big difference between a reinforced concrete building system and a building system with wooden structure and with adobe. Again, from the same publisher, this Building Biology book, some examples, the other examples, but you can jump them now. These criteria here, these columns, minus, 0, and plus, it's a simple system what they did use. And these are 25 columns here, and these 25 columns are these 25 criteria of the building biology and ecology. So another thing is in the building biology, the bioclimatic diagnostic. We are measuring the effects of the indoors of the houses. We can measure, there's an international system, the effects of our health. And we measure the furniture, the electrical system, the paintings, the coverings, and the heating system, etc. And with electronic equipment. For example, also the radiation, the formaldehyde gases, the VOCs, and the dust and the mites, etc. And after that, we can say why this building is making sick us. We are using this formula when we work, and in these three groups, and electrosmoke, the bacteria, allergens, and toxic influences. And one example was nearly 30 years ago, my PhD thesis in Maslak. Here you can see it once more. It's the Maslak campus of the Technical University in Istanbul. And during that time, there were two little kindergartens. One is this, built with adobe, earthen materials by Ruhi Kafescioğlu. And just beside that, there was a concrete kindergarten. And my work was to compare them. Not to compare also the buildings, to compare the kids, how they behave, how the healthy situation of them is, etc. And the result, I'm sorry, it's in Turkish now. the result was the heat, etc., was in the Adobe kindergarten 28% better. The moisture was 19% better. The radioactivity, I will explain that at the end. So electrobiology, the electrical fields, magnetic fields were mostly in these Adobe kindergarten better. And the kids were healthier. And only the radioactivity of the Adobe kindergarten was much more worse than the concrete kindergarten. And the reason is, I will show it now, the reason was these ceramic flooring. So the whole kindergarten had a ceramic flooring, and the radioactivity of these ceramic material was so high that it affected the indoor. So that's a very important result for us. Now, jumping back to our house, as a, let's say, important example now, it's here in Pathologic between Urla and Çeşme, in between. That's our little village, 220 people are living here. And that's the render of the house, and 3 metal roof parts and 2 roofs with earth, flat roofs. The wooden structure, you can see it here. And the walls are completely different in 4 different types. The green ones are more the walls which have a more heating isolation capacity, and the red ones, more looking to the south, to the southwest, are walls which have a heating storage capacity. So the reason is, from the north, I have to protect the house against the wind, against the cold. I need more heating isolation. On the south side, I have to protect the house in the summer against the sun. Otherwise, I need an air condition. And we didn't want to have an air condition, so these are these 2 different types of systems were implanted and built here. The direct and indirect sun influence, especially in the summer, these direct influence, we don't need it, we don't like it because it's too much, and the indirect sun is much more comfortable. And these windows on the upper are cross ventilating windows. The location of the house is very windy. We use that wind for keep the house in the summer period cool. The wind goes from one side, goes in, and from the other side it goes out. We have a cistern and collecting all the rainwater from the roof, and are using this rainwater in the house. And sure, these thermal collectors for the warm water. And now at the end, some pictures from the construction, how it was constructed, sorry. And now here go on. Here on the outside, we have this diagonal covering with, again, with wood. And we made that instead of, I turn back, instead of making here in the structure diagonal structural elements. I wanted to not to do that, and the reason is to have here everywhere very clear forms, not triangles, because if I have here triangles, to fill it with adobe bricks or fill it with some other materials is not so efficient. Here we can see the roof, and that's, for example, the north side. On the other outside, there is this heat isolation we use this reed, 5 centimeter, and then these adobe bricks. On the south side, we don't have this reed, we only have completely these adobe bricks. And it goes on, then we use these clay panels. They are for the first time in Turkey in this building used clay panels. And in these clay panels, we make these wall heating systems and then the clay plaster. So the heating system is a radiation heating system with a very low temperature, but on a big surface, big as possible. And roof heating isolation, then these metal zinc from the roof. The inside looks like that now. Another picture. And here, for example, you see these white walls. These are also earthen. It's earthen painting. It's a kaolin kind of clay, and it's not a chemical paint. It's a natural earthen product, but it looks white. Some other own pictures. Let's jump. So another important example is in Austria, in Vorarlberg, this Omikron building, and it's a wooden structure. And here that's the south facade, which is producing electricity, but that's not so important. More important are inside these implementations. These are the offices, so it's on the IT sector. So they are making computer, yazılım, wooden frame, but the offices are these kumash or these earthen and these wooden structure, for example, and the worker. They are sitting here in a very casual way and with their laptop and are working in a space like this. Also from the inside. And also here these structural frame systems, for example, are exactly 40 centimeter high that people can sit on it. A lot of nice details inside. The Omikron campus is a very important example because it shows us that with earthen materials, with natural building materials, we can also build in a bigger way. We can also build schools. We can also build commercial buildings. We can also build buildings where hundreds of people are working inside. It's possible. Sorry, that is again the biohouse. And the last example now I want to share is in Switzerland, in Claro. The Trissel is the family. And I worked on that design in 1998, years ago. So the most important thing of this building is that it doesn't have a heating system. It's on 1,650 meters. Now I can show it here. This house, and in behind this is Bellinzona, Basodino, the mountain, the more than 3,200 meter high, and the location was very interesting because it's in the Alps, in the mountains, and the reason why we could build it without any heating system was in the summer, in the winter, the dust, the fog is in the valley, but not here where the house is. So the sunny days, it has a lot of enough sunny days. This does show it better. now Bellinzona, the valley bottom. This is the fog zone. And the second is the shadow zone, because it's in the mountains, and on the east, on the west are again mountains, but the location of the house is here, so it was enough to have in the summer during the day enough daylight. So that's why we could design it with a passive system. Sorry, let's go back to this. Okay. The south facade, this is a 60 centimeter thick trompe wall, earthen wall. And here you have this winter garden, and thanks this winter garden, this trompe wall is heating the house. The other facades, the east, west, and north facade, is completely covered with heating isolation materials. So that example showed us that with studying the location, studying the climate, if you know in the winter how long the sun has an influence to the location, if you know how many sunny days are, how many rainy or snowing days are, etc., you can bring these informations to your design. And in the winter, it's permanently under -degree, but also even under that circumstances, it was possible to make it without a heating system. So let's go back, and that's the last one now. Thank you for your listening, and I hope it was very fast. I think I had to jump from one to the other, but I hope I could use the time now as efficient as possible. Thank you very much.
Thank you very much. It was really very stimulating, I think, and informative for all of us and for the students. And thank you for using the time that efficiently. I think we all learned a lot. And I think it had been very helpful in understanding the essence and scope of building biology and ecology. So thank you very much again.
Yes, thank you.
Dear,
and I hope my English didn't cause any chaos.
No, it's not, our mother language for, any one of us. So, no, I think it was, very good. Thank you very much. So maybe at the moment we can turn to our audience and students. Dear students, and also the audience, you can ask your questions. You may write your questions to the chat box or raise your hand to ask your question. Sometimes formulating questions may take some time. We met before with Tanya Hoca, and we worked a bit on the students' questions because there were many, and we don't have that much time to direct all the questions to you. We somehow grouped them, and we prepared a warm-up question also while waiting maybe for also the other audience to formulate their questions if they have. Maybe Tanya, you may want to ask the first question while waiting.
Okay, I'm curious about like the difference about the sustainable architecture and what your approach about biology, buildings, and ecology. So if you can maybe just precise a little bit this thought.
Now I have to understand the question correctly, not to say the different.
Yes. The difference between what we call and what we can see in every school of architecture is like sustainable design, sustainable architecture, and your is biology and ecology. So can you explain the main difference or the approach, the different approach about the
Yes. I think there's not, we can't say that they are different things. They are touching each other very much. But I think it's difficult to explain, but biology is directly the influence to our health. And so the architecture is a very big part of it now, because we spend nearly, the numbers say that 90% of our life we spend in indoors. And that wasn't in the past like that. So the influence of these indoor performances to our health is now much more important than it was in the past. So sustainability is, I think, more genel bir üst şemsiye olabilir. Nasıl tarif edelim bunu?
It's like the umbrella term, maybe then.
Umbrella term, because with sustainability, I'm more working, for example, on social sustainability. So,
yeah,
difficult to explain it now, but
which include like the human part somehow.
The human forms, the social life, and to be in situ, or to be, I have to say it in Turkish now, yerine aitlik duygusu. How can we transform that? Yerine aitlik.
In fact, yeah, maybe it can be formulated with different words, I guess. In the sense of belonging, the feeling of sense of belonging.
Belonging to a certain living space. So the relationship between the living space and me, if I'm in a city, if I'm living on the 7th flat in an apartment, is not so big. But in more communities, living spaces, which are more, let's say, with a more environmental awareness, they try to protect their living environment. And that happens more in the rural, or that happens more in little communities, but not in big cities, because the people are no more anonymous. So that's also sustainability for me. It's not only architecture. And for example, if we design, let's say, apartment or a little living space where what Toki does, 5,000 people will live there. They are building in 1 year, they are building a new, mahalle for 5,000 people, and many different people from all around Turkey come there and start to live there. So how can we measure the performance, for example, of this new living space? Shall we measure the performance with the carbon footprint, or shall we measure the performance with using sustainable materials or natural building materials. In that case, my opinion is the performance should be more we can tespit etmek
to find out, or
we have to find out the performance of this new living space more, for example, in the law department, in the police department of that new community. If the crime is rising, if the hukuki davalar are hukuki dava, if the criminality
case, law case, criminal
rising,
cases maybe,
then we can't talk about a well-being living space. So the priority of the performance is the well-being of the people, and if they are happy, then they start to protect, then they start to get in touch with their new living environment. But if they are not happy, if the crime is more, if go to the police department and take this information. The informations of the carbon footprint calculations, I think, are not so important in that case.
Yes.
So that's for the building biology point of view. These kind of performances are more important than the I will repeat it now, the carbon footprint calculations, for example. Yani mutluluk oranı, iyi yaşam hali. And for example, we know that Le Corbusier did a lot of mistakes in that case.
Mies van der Rohe too, I guess.
In Brazil, in India, they designed living spaces, cities where the Indian people didn't get in, and they preferred their little slum houses, etc. So, and in these ghettos, the crime started, and the prostitution started, etc. And the architect is responsible for that, or is one of the responsibles.
By the way, for while we were searching for the word that suits for, belonging to the sense of belonging, there was a contribution from Sinem Hoca. She has written that maybe it's indigenous somehow. Maybe before continuing with the questions of our students, I see the hand of Maan Hoca.
Yes, I have a question.
Please.
Or
yes,
maybe,
please.
Comment. Thanks for the presentation. The social aspects of design is really very important to be taken into consideration. You said that the social aspects of the design is changing from one place to another. But I think also the social aspects of the design is evolving in the same place. It depends on the evolution of the social habits of the society. For example, like 50 years or a century ago, several generations are used to live in the same house. So if we want to take this aspect into consideration as architects, so we have to think about a house for multi-generations. While recently, this is not the question, even in the same city, even in the same neighborhood. Or in the same neighborhood, no, maybe not, but even in the same city. So aspects of social sustainability is changing between rural areas and even also areas in the same city, but it's also evolving. It's not only changing, it's evolving. And we know that the design of the old neighborhoods in our cities takes into consideration the environmental factor into the question, because they are depending, or they were depending on local materials, not on imported materials or non-environmental materials like PVC and others. Even in the finishing of the house, it's always local materials that are more or less environmental. So I think the recent development of cities didn't take into consideration the social aspects of the design. Here I'm talking about the urban, not only environment, not only architecture, and at the same time didn't take into consideration the environmental aspects of the design, because we see buildings, the international architecture, we see the same or similar buildings in Denmark and in Dubai. So
yes.
Thank you, Manuja, for the contribution.
Thank you. Bye-bye.
Thank you very much.
Thank you very much.
Identities are also changing, I think.
Yes, for sure. Yeah, it's also very critical. I mean, so time seems to be a very important factor here again, I guess. I mean, anytime, of course, you can raise your hand or write to the chat box. So maybe while waiting the questions from the audience, we can continue with the questions of our, first year students. In fact, since they are working on the project, they have some technical questions and more, open questions, in a broader perspective. For instance, one of our students is asking about the limits of being self-sufficient. We know that it's not easy. Would you like to elaborate on that? The limits of being self-efficient or self-sufficient?
It's a very, very good question. And it's nearly impossible to say that's the limit. Because, but we know that we never can say that it's a self-sufficient building. We never can say it's an ecological building. We never can say it's a green building. As soon as we start to build it, then it's over to say that. So we only can talk about good performance as much as possible. And I can't hear the words, it's a green building. I can't hear the word, it's a passive house. I can't hear the word, it's blah, blah, blah. So it's not. And even, for example, in Uganda, in Kagoe, this very simple earthen house, we can't say that it's 100% ecological because it's built. It needed some energy. So you don't have
actually,
a...
sorry to interrupt you about this, Uganda example, because I also experienced a travel to Senegal, and I saw like some houses made by this insect, this termite houses.
Yes, yes.
And it was very interesting because they were building a house, like all the village, building one house for one member of the family or something like this, and they were waiting that the house would be destroyed by itself, and a few years later they would let this house, and construct a new one, like a kind of circular, assuming that a building is dying somehow, and that's the life, and they were doing it again, like every 2 years or every 3 years. So when you mention your example in Uganda, immediately I thought about this example.
Yes, maybe after 50 years or 10 years, whatever, it can break down, and then it's again a part of the earth. So it's coming back to the question. That's a good example for these sustainable performance, but it's still not 100%. So if we say, for example, if we are talking about a passive house, okay, first you have to, amorti etmek, bring the it has to save the energy for that energy for what it was built, and that can take a few hundred years. So it's like when we are starting, let's say, a football match. When the game starts, we are 0 to 0, 7 to 0 in behind. So we have to shoot 7 goals, then it's 7-7, and then we can start to say, now the story begins. And it depends on the building materials, mostly. Shall we start the game 7 goals in behind or only 2 goals in behind? The building materials have a very big influence for that performance, for that scenario. And that's why it's also the reduce, and if we have to build, do we really have to build it? Is it really necessary to build it? These decisions are also very important, I think. We build so much what we don't need. Doesn't matter if they are commercial buildings or houses, etc. So I have a client here. He wanted from me a design here in our village. A very rich family in Istanbul. In Istanbul, they are living on the Bosphorus in a villa with a big garden, etc. The next house is in Bodrum. There they have their summer house. They are traveling a few times in the year to the Maldives or to Switzerland, skiing, etc. And that isn't enough. Now he wants a house here in Urla. So this doesn't have to be. So,
so you refused it?
I said my opinion. Do you really want it?
Congratulations.
Yani şey derler ya, gözün doysun.
Yeah, that's really very interesting. I mean, I really wondered about their consideration or conception of ecology, or what they dream of somehow. Maybe you also did too.
Yes, so we have this house here, and I don't have another house somewhere else, and I don't have another ground somewhere else because I don't need it. And so that's, I think, also valuable.
There is a political vision in your settlement somehow.
Or ideology, yeah. I think it's more about the ideology somehow.
Germany, for example, you have one house and you pay the tax for that house, and if you have a second house, you are really punished because the tax of the second house is so high that the people don't buy or don't build a second house for them. It's a social system. One is enough for you.
So maybe sustainability is also more about not building if it is not necessary.
Exactly.
Rather than building.
Yes.
O
süreç tasarımı. We will build it, and afterwards, what will be the effect, the social effect of this house? A school, a house, whatever it is, doesn't matter. So, is it really?
Can we ask you about your house now? You said that you introduced saying that you have these 3 individual building materials and the processing quality. Was it difficult to settle this new house, thinking about the construction companies that don't have the knowledge to do such Western architecture, for example, or Adobe? How did you manage to build this house?
It was, I spent very much time for that. Nearly for everything I had to work. And finding also the people who can build it, so the wooden frame system, for example. Because there are a lot of little details and that geçme sistemleri, that we don't need metal fixing elements as less as possible. So if you work with a big company, there are a few in Turkey, they have their system, and you can't, or I can't work with them because they don't make what I say. They say we have our system, take it or leave it. So I had to spend a lot of time, but we were very lucky because nearly all of them were local people or local companies, and very valuable relationships started with that. Most of them are good friends of us now, and some are now making this cross-laminated timber, etc. I work with them together, so they developed their producing and işte bu baskı şeyleri, hidrolik lamine kiriş sistemleri falan. So I also work with them on the engineering part of that. And the reed, for example, this reed heating isolation material, and it's in Antalya, the producer, but he never did it before. So first I sent him a little prototype. Okay, I can do it. Then he sent it back to me. It was wrong. Then I went to Antalya and we worked on it. And now he's producing it in a very perfect way. So in Turkey, everyone can call him now and buy it from him. Things like that. So yani vesile olduk birçok şeye aslında.
So you were experimenting by doing, actually.
Well, I didn't have to do it if I had the possibilities which I had in Germany. But the craftsmanship here was a new experiment for me, and it was our decision, it was our risk also. But well, it's the Merve and me, it's the way we like, and we say that's important for us, and we are glad now to be able to say, thanks to that period, thanks to that building, now other buildings, the following buildings, are buildable much more easier. It's also important that the building materials and the craftsmanship must be available, especially the building materials. And these are, they don't have to be these, I say, hippie solutions, like I did in Germany in the previous time. And but now companies are producing these, and thanks to that, it's available for all architects. It's available for these materials are available for all the sector, and that's the only way that it's that the market can grow, the natural building market in Turkey.
Mm-hmm. In fact, during your presentation, also now, while elaborating on the questions, you answered some of the group of questions we have prepared, but still, when our students started searching about ecological materials and maybe architectures, I think they came up or with the examples which are mostly in small scale. I mean, residential, buildings, etc. In fact, during your presentation, also you mentioned that it can be a school or any type of building. But many questions ask this question. I mean, is it possible to build a multi-story or a larger scale building in an eco-friendly way? Somehow, I think the examples they have found made them think about this scale issue. Is it possible to build a high-rise building with some ecological materials, or maybe you can suggest some examples that they can search for?
It is possible, but the performance is different. Mm-hmm. So with wooden frame structural systems, we can build, I think in Austria, in Vienna, is a 24-story high building, Hoho called. I visited it when it was in the construction. In Norway, they are building 30 storage wooden structure system, etc. It's possible. My question is it necessary? That's another question. So, okay, is it necessary? That's one part. But if it's necessary, okay, if it's necessary, then also in Turkey now, we can, in Istanbul, in the middle of the city, you can build a high-rise building with a concrete frame system, for example, betonarme or steel, whatever. And then you can go on the rest with these natural building materials. So in that case, you can say I have a 40-story high-rise building in Nişantaşı or in Maslak, whatever. And 20%, 25% of this building is built by concrete. The rest, 75%, the rest 70%, whatever it is built by urban building materials, is built by natural building materials. That's possible. Mm-hmm. And the declaration, as long as the declaration is, transparent, then why not? It's a good decision, and it's a good example in that case. So many people ask, yes, but we are in the city, so we are the unlucky one. We can't reach these kind of buildings because we are in the city. The answer is no. Even in the city, you can do it.
Yeah, I think that's a very important point to mention.
Yes, these clay boards, for example, they are very important instead of using these gypsum boards. Mm-hmm. The same craftsman people, the same worker can do it. You don't need an extra knowledge on the construction to fix it. Mm-hmm. You only have the material must only be reachable. And that's why the natural building material sector in Turkey, my opinion is that it has a very big perspective and future. So the next 5 years, the next 10 years, this sector will grow.
Mm-hmm.
You are introducing new topics and more questions about urban density and the challenge of tomorrow. So I really thank you for all those new openings, let's say.
Mm-hmm.
Çaresizlik nedir İngilizcesi? Çaresizlik.
Desperate, çaresiz.
Desperate. So if you are in a big city, you don't have to be desperate or don't have to feel. But it's also the big politics. So Istanbul is a very unlucky example now because of this concentration and trying to find solutions with more roads, more ways, etc. Every new road is inviting a new density. So maybe the politics has to stop to make more for Istanbul.
Mm-hmm. Yes, you're right. In fact, this topic, I believe, made our students to think about various issues like the lifetime, or even there were questions about the earthquake, for instance, the relationship of, these ecological materials, their performance regarding the earthquake, or, the difference between the lifetime of ecological materials or architectures with others, the scale issue. I think it has been really very stimulating for them to somehow start thinking and raising awareness about sustainability. I believe, in fact, as I have mentioned during the presentation and explanations, you have already answered most of the questions somehow, so I don't want to bring them again. Most of them will be kind of repetition maybe. I don't know, Tanya, if I am skipping a question that has not been discussed yet, you can just remind me, but it had been really very stimulating in that sense. So I want to thank you once again, Akman, for this presentation and all the discussion about the topic. And maybe we can turn to our audience for the last time for asking whether there are more questions. And I'm also checking the chat box. I think we don't have.
Okay.
Yes, Melat Hoca. Yes, please.
Yeah. Okay, I'm sorry, I couldn't be sure about asking, or I'm not sure that I have a question. This craft question, but let me say something maybe. Thank you very much for this very, fruitful lecture, Mr. Akman. I always find myself in thinking about if it's possible to, make any like diagnosis, to the buildings that are now existing. Can you understand what I mean? Like, not building new buildings, but making some revisions on them to make them more ecological somehow. Lightening them up, maybe. You were talking about these high-rise things, much like Istanbul case, like a desperate situation, and so I'm an interior architect, for example. And I'm facing with already built structures. So, I mean, do you think it's possible to incorporate these ecological cures to the still existing buildings? Just some thoughts on my mind. You can throw it to the trash.
Thank you very much. It's possible and it's necessary, I think.
Yeah.
It's necessary because the existing buildings, we can't say that let's forget the existing buildings. Millions are living there, and we never can say let's demolish them and build it new. So we have to protect the existing buildings and bring them to the standard which we need today. So in just a second, I try to find in Germany, I found it. The governmental institute, Federal Institute for Research on Building, Urban Affairs, and Spatial Developments. They have, for example, these criteria, and they split it into their criteria. One part is for the new buildings, but parallel to them, also for the existing buildings, they have the criteria. So
actually, the last Pritzker Prize, Lacaton and Vassal, the main focus of research is about the renovation of existing building in terms of energy efficiency and also social communities.
Yeah, my question was, I think it was related with the last words you said about, I mean, constructing a building 20% out of concrete and 70, or 80% out of some earthy materials, let's say. Yeah, I mean, is it possible to apply this, implement this to existing one? I mean, destroying the concrete parts, and redoing it. So just a kind of wish, maybe.
Yes, destroying the frame system, no matter if it's concrete or steel or wood, destroying this.
Not the structural loading structure.
Means destroying the whole building. So in that case, that's not a renovation. Polishing and building it in a new way. To rehabilitate or restore wooden buildings is much more easier, because in wooden structures you can change parts, what you can't do in concrete structural systems.
Yeah.
So, that's an advantage and a disadvantage for one and the other. But I know restorations in building biology, we use the word rehabilitation of the house.
Rehabilitation, yeah.
It's not a restoration, it's a rehabilitation of the house. And rehabilitation for the ecological values, that means the building must use less energy for its heating and cooling, etc. And the building must be more, from the point of building biology point of view, the building must be able to protect our health in a better way. So these bioclimatic diagnostic in Germany, I can't say it exactly how much, but more than 600 times I did it. And I earned a lot of money with that. Because the people, they came mostly from the medical doctors. So they have, let's say, asthma or whatever their healthy problem is. They go to the doctor, and instead of giving him aspirin, like a symptom healing, the doctor says, wait a minute, your asthma is caused by, for example, where do you live, your kindergarten, your house, etc. Or also the what do people eat. So these two are very important. The food and the houses. So organic food is now very normal in Migros, etc. We everywhere can see organic food. Places, but in Koçtaş, we still don't have any natural building material parts. But this will come in the future, or must come.
Yes, I agree. I think that was really very interesting to hear. I haven't even think about that, but why not? It should be really.
Yes, we are working for that. So I hope we will see a good result in the future. When it will be, we can't say it, but it's nice to work for that.
Thank you, Melahat Hocam.
Thank you
for the contribution.
Thank you.
Thank you. Thank you so much.
Maybe now we can leave the screen to Elif Hoca, our Vice Dean, for the final words.
I want to thank you all for the participation, students, hocalarım, and for the questions. And Mr. Akman, I want to thank you. I want to thank you for this interesting presentation. It has been great having you here. So we have a little tradition in ArchiDesign Talks. As Bahçeşehir University Faculty of Architecture and Design, we make a small donation in our guest's name. So now you have 3 young trees in a memorial forest in Turkey, in Elazığ. So thank you so much for all your time and effort.
Thank you very much. And again, sorry for these technical problems. You can't see me, couldn't see me. But
and don't worry, at the beginning we could see, we had the possibility to see you in a short for a short period. But thank you for the very interesting presentation. Thank you very much.
You're welcome. Thank you very much.
Thank you once again.
Thank you, John.
Okay. So let's keep our keep in touch, stay.
Yes. We will, of course, keep in touch. And thank you once again. Also, all the students and the audience are thanking to you from the chat box.
Okay. Then
Thank you.